Hey everyone, I am Priyanshi Agrawal and welcome back to my channel. Today we will be solving Leetcode daily challenge, which is insert greatest common divisors in linked list. So we can understand from the question name itself that what we might need to do in this question. So let's see what is this question and how we can solve it. So in this question we have been given the head of a linked list head in which each node contains an integer value. Okay. Between every pair of adjacent nodes, insert a new node with a value equal to the greatest common divisor of them. Right? Okay. Return the linked list after insertion, and the greatest common divisors of two numbers is the largest positive integer that evenly divides both numbers. Okay. So let's see what we need to do in this question is that this is our input is linked list. So in this linked list in this question we have been given with a linked list, and what we need to do is that we need to insert a node between every pair of adjacent nodes whose value will be equal to the GCD of these two adjacent nodes, that is 6. GCD of 6 and 10 is 2. Similarly, GCD of 10 and 3 is 1. And as a result, this will be our output linked list, right? So it is quite a simple question. We just need to iterate the linked list and just insert a node between every pair of adjacent nodes whose value is equal to GCD. Okay. So in this question, first what we can do is we can just use the invert GCD function of C++ to find the GCD of these two numbers. Okay. But I will tell you how to implement this GCD function, because sometimes in interviews we are not allowed to use these kind of a standard function directly and we are asked to implement these. So I will tell you that how we will be implementing this GCD function. Okay, so let's say our A is 18 and our B is 6, right? We need to find the GCD of these two numbers. Okay, so GCD can be less than or equals to the minimum of these two, right? GCD will be less than or equals to minimum of A and B, because like if GCD is like among this minimum is 6, B. If GCD is greater than 6, then let's say 7, then obviously it cannot divide number 6, right? So GCD will always be less than or equals to the minimum of A and B. Okay. So what we can do is we can simply start iterating from minimum of A comma B till 1, and we can check for every integer that whether A modulo by this number, let's say we are using this as I loop, is equals to 0, and B modulo I equals to 0. If yes, then return I. Then I will be our GCD in this case, right? What will happen in this case is we will be using this complexity as M. Let's say M is the number. So this is a kind of linear iteration in which we use the complexity of M. And let's say our linked list length is big O of n, and for every adjacent two nodes we are using this method to find the GCD, which has linear complexity of M. So its complexity will become big O of n into M, where M is the greatest value of the node which can have, right? And n is the length of the linked list. Okay. So can we reduce it to some logarithmic complexity? Okay, so let's see again. So A is 18 and B is 6, right? So in this case, write A modulo B, that is 18 modulo 6 is already 0. That's why its GCD is 6. Okay, but this is quite straightforward example. Let's take another example in which we have 6 comma 10 as pairs. Okay, so let's say A is 6 and B is 10. So among this, 6 is smaller, so let's say I will swap these values. A is 10 and we will keep smaller value in the B. Okay. Now let's see how we can find the GCD and reduce the linear complexity. So we will be doing A modulo B. Okay, so 10 modulo 6 is 4, right? Now again let's divide 6. Now we will do 6 modulo 4, which is 2. Now 4 modulo 2, which is 0. Yes. Now 4 modulo 2 is 0. Now again 2 modulo 0. This can't happen. So we will break this loop and we will get our GCD as 2. Right. So what we are doing in this case is we are taking two variables A and B and taking the modulo of them, and this is our remainder, let's say. And what we are doing is we are replacing this A variable by the value of B. Okay, we are replacing A by B and B by the modulo of A and B, right? B by the modulo of A and B, right? Till when? Till B is greater than 0. If B is equal to 0, then we will simply come out of this loop till B is greater than 0. Okay. And what will be the GCD finally? GCD will be this A value, right? So if this is, then we will return our A, right? So in this way we can compute our GCD in the logarithmic time complexity, because as we are replacing this A and B by their modulos, so its time complexity will become big O of log of m. Mathematically its time complexity is logarithmic, right? So we have reduced this time complexity from linear to logarithmic. Okay, so let's see how we can code this. Now we just need to find the GCD and insert it in the linked list. So let me first just create our current pointer, which is pointing to the head node. Now while we have current pointer not pointing to null. Now we need to keep the track of the next node as well, current next of current. But what if there doesn't exist any next node? If there is no next node, then we don't need to find GCD, don't need to do anything. We will simply return the head node. Otherwise, we need to create a new node, this node with the GCD of current node and the next node, right? Either you can use the inbuilt function of GCD just like this, but I will be showing you how to implement it. Okay, after this what we need to do is we need to store that new node in the next of the current node, and that new node next will store the pointer of this node, right? As you can see, now this new node will store the pointer of this next node, right? Okay, and now our current node will become the next of current node, because the earlier the next of current node was this, but as we have inserted with this node between these two nodes, and we want to make our current node point to this 6, so that's why we are incrementing it by 2 pointers. Okay, now when we come out of this loop, we will simply return our head node. Now let's implement this GCD function. So it's will be int GCD int A comma int B. Now while B is greater than 0, so what we will do is we will simply replace A by B and B by A modulo B. But see, here we have already replaced A by B and we have lose the track of A value. So we will create a copy of A as A, and we will use that copy of A to replace to change our B value, and by the end of this loop we will simply return A. Okay, so one thing, if you are clever, then you must have noticed that thing is one thing here is that I have told you that we are storing the smaller value in the b, right? We are storing the smaller value in the b, but while implementing I have not done any kind of swapping or nothing, and we are just passing simply 6 comma 10 here. We are simply passing 6 comma 10 here, right? But see, the beauty of this algorithm is that here copy of a stores 6, right? And now a stores b, which is 10, and now b stores copy of a, that is 6 modulo b, that is 6 modulo b, which is equals to 6. Now our pair becomes a comma b becomes a value is 10 and b value is 6. So automatically v is storing the smaller value now. So this is the beauty of this algorithm, that we don't need to swap these values separately. Okay, so let's try run this approach. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So let me tell you its final time complexity as well. So as you can see, we are using this one loop for iterating the linked list and this GCD loop inside that loop. So its time complexity will become big O of n into logarithmic of m. This is for GCD and this is for the linked list, right? So yeah, that's all for this question. I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Bye guys, see you in the next video. Till then, keep learning and stay curious.